So this is the next question we have. It's mostly around resource allocation. Again, pause the video and read through the questions. So we have 3 replicas. Each has 2 containers. Total we have 6 containers. And the pods are not starting. We have some issues in the pod. They are not starting. Mostly due to resource constraint. From this particular example, we can guess that. Also, we can look at the details or the described pods to see the actual problem. But it is kind of evident from the question that the problem is resource. Give each pod a fair share of CPU and memory, which means that give the pod decent amount of memory such that it will run. Now, what is this fair share? That is the trick with this question. If you're going to calculate all those things, you will be running out of time. I'll tell you how to calculate approximately, at least. Definitely don't do that in a production scenario. Sizing in production is a whole different business altogether. So don't use this kind of techniques which we are going to see in the real world. This is just for exams. I'll be discussing some kind of calculation and all those things. Even that cannot be used in the exam because of the time constraints. So what is the fair share? We don't know. And the calculation is not straightforward, as you will see shortly. Now, what is being checked in the exam? All the pods are running and ready. That is what is being checked in the exam. And that's what we are going to try it out as well. Making these pods running and ready, that's being tested in the exam. Whatever it takes to make these pods run and ready, that's what we are going to focus. First, we need to reproduce this issue outside the context of exam, of course, in our playground. And then we'll try to adjust a little bit. We'll look at a couple of counters and we'll get a feel of things without calculating it. Now, let's get into the answer. The answer is to use resource request. They have already mentioned don't change the limits. Probably the exam resource or the deployment may have limits. We are not going to change it because it is specifically mentioned in the question. You're not required to change any resource limits. There is something called resource limit and a resource request. We are going to play within the boundary of request. That's what we're going to do. Similarly, in the exam, there are 2 ports, in fact, 2 containers inside the same port. So there is an init container and a friend end. Both are Nginx and BusyBox, respectively. And each of them is requiring high amount of memory and CPU, as you can see here. This is not the answer we are looking at. This is the question itself. The answer is yet to come. And we have 3 replicas. So total 6 containers. So there is 1.5 CPU cores. This is 1.5 CPU cores. Each CPU core is 1000 M in terms of the units which Kubernetes uses. And GI is almost GB and MI is MP, more or less. And 3 GB and 1.5 CPU. That is what required by this one guy. Like that, there are 2 guys here, 2 containers. So total 6 into this is the request. So 18 gig and 9 CPU cores. That's pretty big. That's like a production system, more or less. I'm pretty sure our playground, the killer code of playground, doesn't have this much CPU and memory. Otherwise, they will go bankrupt in no time. Assuming that, what we're going to do, we are going to copy this thing and paste it there. Although it is called solution.yaml, it's not really solution.yaml. Don't go with the name, just listen to what is being told, in this particular case at least. So what I'm going to do is I'm going to copy this, Control-C, and going to go to the playground and going to create a YAML file, 1.yaml, and I'm going to paste it. We'll look at the CPU and memory of the system later. For the time being, let's see some bad stuff. Okay, apply, -f, 1.yaml. Let's see if we are getting some errors. We're not getting any error. It has created successfully. Now let's check if the pod is running. Okay, get pod -a. We're getting all the pod. As you can see here, the pods are not in the running state. They are in pending state. Now let's see the reason behind it. Instead of get, I'm going to do a describe here. Pretty much the same command, describe. As you can see here, this is the error right here. Failed scheduling, and there is not enough resource, insufficient CPU and memory right here. So that's the error we are getting when we are requesting too much memory. What is too much? Why it is too much? For answering that question, let's look at the node. We don't need namespace. This is the node we are having and the details of the node. So the node has only one CPU. We requested for 9 CPUs, but we have only one, very less. Now, how much memory it has? This is in KB, more or less. It has only 2 GB of memory, not even 2 GB, less than 2 GB. This many MBs, hardly 2 GB. And we requested for 18 GB. I forgot. Something big we have requested while we have only 2 GB. Now, where did I look? I looked into the allocatable. There is capacity, there is allocatable. Again, don't do this kind of calculation which I'm going to tell you in production scenarios. I'm warning you that because this doesn't work in actual real scenarios. Why this is different? Because there are other things running in the system. The kernel is there, the operating system, the processes, the Kubernetes itself, kubelet, kubeproxy, CNI processes. A lot of other things are running along with the pods we are going to deploy. So they have used up some share of memory and CPU. So we need to leave some memory and CPU for the rest of the system. And then divide this value between the pods. Now, if we divide this value with 6 approximately, we get around 300 MB. And this is 1000. And if we divide that with 6, we'll get around 150. Now, in our case, I'm going to leave a little more room for the system. And I'm going to select 100 for the CPU and around 150 as a memory, or even 100 for the memory is not a bad decision. So there is no hard and fast rule. In the exam, what do you need to make sure that look at these numbers and come up with an approximate value like this rather than calculating the whole thing. It'll take time and it doesn't make sense. Your time will go. You don't have time for the full calculation. At the end of the day, your port should be running and all the ports should have equal amount of share. That's the condition of this question. Now let's try that. So I'm going to edit the pod, edit the deployment. In my case, what I'm going to do is I'm going to edit my request. So this is going to be 100 MB. And if it is not going to run with 100 MB, I'm going to increase it slightly, but I'll start with 100 MB. So in the exam, look at the allocatable memory and probably multiply this 100 with that particular amount. For example, if it is 6 GB, multiply this 100 with 3 and so on, rather than calculating the whole thing. So 100 MI, and this is also, I'm going to put just 100 right here. One more port I have. I'm not going to change the command. Same, I'm going to put it here as well. 100 MI and 100 M. So these are the configuration I'm going to try. I'm going to apply it, and the ports are slightly starting up. One is started. Let's try again, and all the ports are started. So that really worked, and this is all we need for the exam. Now, if you're going for the calculation in the real world scenario, you need to look at the loads. You need to look at what are the resources you're planning, auto scaling, carpenter, node auto scaling, a lot of different factors to consider. But this is just for the exam we are talking here. There is a single command, kubectl command. You can refer it out to change the request. The whole thing can be done in a single command rather than going with the YAML. But normally I recommend using YAML just for clarity, as well as in case if you want to change it later, you can do that. Thank you for watching, and I'll see you in the next question.